Hey guys, this is Stella from Dr. Rizk 2430 Data Structure class. In this video, I will be explaining my solution for homework 4. It's not the most efficient code that I can use, but it is what meets the minimum requirements of this homework. So it's very basic, very easy to follow, and we'll focus on concept and implementation of Q. So let's get started going through our instruction and see what are things that we need to implement in order to get through the test cases. Okay. So in this assignment, we'll be given a few strings containing random characters and a list of instructions for how to decode the messages. The instructions are out of order and a priority queue must be used to initiate the commands in the proper order. So first of all, we see that we need a priority queue to store command, and when every command is put into the priority queue in the correct order and each command is performed, then the program will decode the message. The input will contain a series of commands. Each command will be put into a priority queue. Each command is case sensitive, and there are six commands. We got 6 types of commands that we may encounter. So decode, replace, add, remove, swap, and print. Each command will be followed by an integer from 1 through 10 that represents its priority in the queue. 1s are the first in the queue, and 10s are the last. If 2 commands share the same number, then the first one put into queue goes first. So what does this mean? As we can see that each command is followed by an integer in the parentheses. We can try to draw our graph just to have a visual representation of it. Let's say if we implement the priority queue as linked list, this is what we will have. 1, 2, 3, 4, 5. Okay, since we're told that starting from 1 through 10, we have higher priority to lower priority. That means our elements in the list will be looking something like this. 1, 2, 3. These are their priority numbers. So here is our head. Head will be pointing to the one that has the highest priority, because whenever we pop, we are removing the one that has the highest priority out of the queue. And 5 would be our tail, obviously. Now, if we want to insert an element that has a priority of 4, okay, so I have a new element that has priority of 4. How do we insert it into this list? We are first going to compare it with 1. We compare them. Does 4 have a higher priority than 1? No, so we're going to move it to the back. We now compare 2 and 4. Does 4 have a higher priority? Nope. Compare 3 and 4. 4 still not higher. So we compare 4 and 4. Now we have a problem. Since they have the same priority, what should we do? And let's take a look at our second half of this paragraph. If 2 commands share the same number, then the first one put into the queue goes first. That means for the new 4 is still going to be pushed back to the first 4. So we keep comparing. We compare 4 and 5. Does 4 have a higher priority than 5? Yes, because 4 is closer to 1. That's why 4 is having a higher priority. So here is what we're going to insert it to. We're going to break the link between the original 4 and 5. We're going to link them like this. This 4 linked to this one, and this 4's next pointer will be pointing to this 5. So this is how we compare the elements in the list and actually insert them. So let's keep moving with our instruction. In this program, there are two queues that must be used. One, the priority queue that takes in every command, sorting them based on priority. We just went over that. And number two, a regular queue that takes in the messages provided by the decode command. Let's go back and take a look at our decode command. It's looking like this. We got a actual decode command followed by a colon, bracket, and the messages inside bracket, and the last digit, which is the priority. So every time we encounter a decode command, we are going to extract this message inside brackets and push the string into our regular queue. So we need a number two, we need a regular queue. What does it do is, let me move it up real quick. What does the regular queue will do is that it stores messages provided by decode command. Okay, every command besides the decode command will affect the top of the regular queue filled with messages, change the string, and then move that string to the back of the queue. So if there are two strings in the normal queue, then they'll be affected by every other command. So this is what it means. Since our queue is a first in first out structure, we have something like this. Let's say we started with two elements in the queue. So these two elements will store message 1, message 1, message 2. So every time we encounter a decode command, we're going to extract the string within the bracket and create a new node with that string appended to the back of our current regular queue. So we got another message, MSG3. We're going to append it here. So the next pointer of this will be pointing to here. And the next pointer of message 3 will be pointing to no. Here is where we will go about appending element to the queue. And according to the instruction, every time we apply a command from the priority queue, we apply it to the first element in our regular queue. And after we apply this command to it, we're going to move this element to the back of the queue. So after applying a command, our list will be looking like this. Here is the message 2. Now it becomes the head. And we have message 3 followed alone. And the message 1 will now be right here. Message 1, and it's pointing to no, obviously. So these are our basic or general ideas of how to go about this homework. And let's go back to take a look at some of the commands we had. Well, let's write something on it. Notice that these commands are made up of 3 parts. First of all, we have actual command and followed by colon, bracket, right bracket, parentheses, and an integer. Since our priority queue is storing commands, we can make our node of the priority queue contain 3 information. First will be our actual command, second will be the message, and the last will be the integer, which is the priority. So we already know what to do. Okay, so let's jump into the actual coding part. So we're gonna first implement our regular queue, which will store the messages we extract from the decode command. And in order to implement it, we're going to need a node to store the message as the information. So we're going to implement it as a linked list. Let's create a node first. Let's call it qnode.h file. We're going to include string because we're going to need it as our type using std. Okay, we're going to create our node as a strut. Let's call it qnode. And I prefer to have it here. We need a string to store our message. Let's call it msg. We need a node pointer pointing to its next element. And let's create a constructor so it's easier for us to create a new node and the functions. We can just call this constructor and build it there. qnode, we need a string parameter, message, let's initialize it with message, and next pointer will be initialized to node pointer. And here's the end of our definition. So we've got a node ready to use, and let's create our, and let's implement our queue. The actual queue, we get a queue.h file. And we do the same thing to find this file. In this file, we're going to include our qnode.h file, so it's going to find it once it's linked. Include qnode.h file. We're going to include the string, library. Oops. Okay, let's get started. Declaring our queue. Class queue. We're gonna have private parameters and public functions. So what do we need in our private parameters? We need a node, a qnode pointer head, and qnode type of pointer tail. So we're going to append element from tail and element exit from head. And we can also add a size parameter, but we don't have to. It's not required for this homework. So, but we're just gonna put it there just in case. And we need some functions to get started. Let's implement the basic ones. A queue constructor, a queue destructor, We need a bool function is empty, no parameters needed. We need insert and remove function, make them void type, enq. We need a string in order to build a new node. We have a dequeue, doesn't need any parameter, we just pop the element whatever head is pointing to. And we need a string, and we need a peek function, which will tell us what's the string message on top of the queue. So let's make a string so we can actually get it. So let's make it a string return type. Peek function. Oops. Okay, so these are functions so far. We'll see if we need to add more functions to it. But let's get started with these. Here's our .h file. We're gonna create a new file. It's q.cpp file. Let's include some libraries and some files we need. We need a IO string, a string. Let's include some files we need. So for files, we're gonna use quotation marks. We need q.h, need q node.h. These are the h files we need. C namespace std. Okay, let's officially get started with our functions. First, we have a constructor. Let's use initialization list to initialize it. Our head will first be pointing to no pointer. So does our tail, no pointer. Size will be initialized to 0 because we don't have anything at first. And we can just leave it empty. We have, here is our constructor. Let's get our destructor. So since every node has a next pointer, we'll have to delete every single element in the list. Let's draw this out so it's easier to see what's going on there. This is our destructor. Here's our list. We're going to delete it from the head. It is pointing to 1. We're going to create a new pointer, cur, pointing to head at first, and then we're going to move head to the next one. That way, whenever we delete the first element, we're not losing our next element. So this one will get deleted, and then whenever we go back to our loop, the curve will be set equal to head again. So now it's here. Head will be the next one right here. and until the head reach no, we're going to stop right here. So what we have is create a new node pointer. Let's call it cur. Condition for the loop stop is while head is no pointer. So while the head is not no pointer, we're going to execute the loop. So set cur equal to head at first, and head is equal to cur. Next, we're going to delete whatever cur is pointing to because we no longer want it. If we exit the loop, that means we have successfully deleted all the elements in the list. And at this point, tail will be set to no pointer because we have nothing left there. The size would be set to 0. And here we go. Here's the implementation of destructor. Now let's do an isEmpty function. Is empty, no parameters needed, and it's bold type obviously. If head is equal to no pointer, we return true. That means it's empty. Else return false. Okay. We need a function peek. Remember its string return type belong to Q class. Peek. We don't need any parameter, we're just simply returning the string of the message. So there are two cases we need to consider. One is when the list is empty, we're going to return a string that says this queue is empty. Empty queue. Okay. Otherwise, we return the message that the first element has, which is head to message. It's actually called MSG. Okay, let's write a note here. Two cases to consider. And others are pretty obvious. Here's a destructor. Now let's implement our enqueue and dequeue function. First do enqueue belong to queue class. Enqueue. We need a string parameter. Let's call it line. So we can create a new node calling the node constructor. Here's how we will use it. Let's call it new node. And we're going to dynamically create it. New queue node, call the constructor of the node, and initialize it with line. So we also have two cases here. One is when it's empty, and otherwise. So if is empty, we set both head and tail to no. Sorry, we set both head and tail equal to the new node. Let them point to the new node. Let them point to the new node, and we increment the size +1, and we leave. Return. Otherwise, the next pointer of the original tail will point to new node, and the tail is now new node. So here's our enqueue. Now we have dqueue, which belongs to queue class as well. dqueue, no parameters needed. We're just popping the first element inside the queue. We have two cases to consider as well. So whenever we have empty queue, we're not gonna delete anything. We're just gonna return it because we can't proceed. Else, if it wasn't returned, if the call wasn't returned, we're going to delete. So this is what it looks like. Get our whiteboard again. DQ. Here's again our queue with the first in first out structure. Whenever we pop an element, we pop it from the head. Here is our head again and again. If the head is not no pointer, we're gonna pop the first one out. This is the first one. We're gonna point the head to the next. And we need a temporary pointer. So whenever we want to delete the first element, we can let the original head point into its next element. That way we don't lose anything in between. So temp will pointing to the original head and head will point to the next element. So whenever we delete the first element, we retain the head, and that way we can repeat this process again and again. And after that, temp will be set back to head pointer again. So let's try to implement this. If it's not empty, we create a new node, pointer, temp. Let's call it temp and equal to head. Head will now be head next. We delete temp, and temp node will be no pointer. Temp will be no pointer. Size -1. And there's another condition. Whenever our head becomes no pointer, that means we don't have anything in the list. We're going to set the tail equal to no pointer as well. So this will complete our DQ function. Yep. We pop from head. So this will complete our implementation of a regular queue. And now let's start with priority queue. It'll be very similar to queue except for the insertion process possibly. So let's do it step by step. We're gonna create a priority queue node. Let's call it pq node.h file. Right, so we're gonna define the file pq node h, define q node h. We're going to include string library namespace std, and we're also using struct to create our node. Let's call it pq node. So as we've mentioned before, in order to store our command, we're going to break the actual command into 3 parts. The first one is the command, second is the message that we are going to extract from the bracket. and an integer representing the priority of the command. So let's do it, giving it 3 parameters: string type command, string type message, and integer priority. We're also going to need a next pointer. So pq node, call it next. Alright. We're gonna have a constructor as well. As we can see that it's very easy to just call the constructor and create a new node from there. So pq node, the constructor will take in 3 parameters: string, command, string message, integer py, meaning priority. Initialization list. We're going to initialize command with command, message with message, priority with py. And our next pointer will be initialized to no pointer. And here we go. Here's our priority queue node. Alright. So now we're going to write our priority queue.h file. Let's call it pq.h. Okay. Let's define it. pq.h. We're going to include our priority queue node file. So include quotation marks. It was pq.node.h file. Here is the file. We're going to include string library and username. Oops. Okay, let's go ahead and implement our priority queue. Private data members, public data members, or functions, you can say. So we're going to have a int size telling us the size of our queue, and a priority queue node pointer, pq node, a head pointer. Notice that we don't really need a tail pointer here because whichever way you want to insert the element, there is only one correct position for it to be. So I'm just gonna go ahead and start comparing from the head and leaving tail out of this implementation. Let's implement our functions. We need constructor, we need destructor, need a bool type is empty, we have the same as Q. These functions are pretty similar to regular Q, and for this peak function, for this peak function, we're going to return a pointer because unlike regular queue, our priority queue will store a command which has several informations contained in there. So we're gonna return the pointer, that way we can have access to other parameters. PQ node. We have our NQ and DQ. In PQ, we have DQ, DPQ. DQ doesn't really need any parameter. However, we do need 3 parameters for NQ function. 3, a string command, a string message, and an int priority. So let's go ahead and implement these. Create a new file, call it pq.cpp file. Alright, we can go ahead and include the two 8.h files we created. Include. We have pq node.h file. We have pq.h file. And include some libraries. IOString. Include our string using namespace std. Okay, function implementation. First, implement our constructor pq. No parameters needed. Initialize our size with 0 because it doesn't have anything. In our head, we'll be pointing to no at first. Here's our constructor. Alright, implement destructor. Same as before, we create a temporary pointer. PQ node, call it cur. While our head is not no pointer, we're executing this loop. Set cur equal to head equals to head next. And delete cur. Whenever we finish deleting, we're going to set size equal to 0. And since we didn't have a tail pointer, we're not going to do anything about it. And this is our destructor function. Destructor. Spell that right? Yeah. Okay. Now we're going to implement our isEmpty function. So make it bool type belongs to PQ isEmpty. What's wrong with it? What's wrong with it? Let's go back to our header file. Oh, misspell it. Here we go. isEmpty. So if head is equal If head is null pointer, we return true. Else, we return false. Now let's implement peek function. Remember, it returns a node pointer. So pq node pointer belongs to pq class. It's called peek function. If it's empty, if our queue is empty, we're going to return a node pointer. Else, we are returning the head. Return head. Okay, this will do it. We got NQ and DQ. Okay, we got our void type. PQ and PQ need a string command, string message, and an end priority. Right, this is good. So let's first create a new node with the parameters we have been passed in. We got, here is how we do it. We get a pointer, call it new node. We're going to dynamically allocate it. New PQ node, creating a node with CMD, MSG, and priority. Okay, we've got our node ready. So 2 cases as well. 2 cases. One is empty and otherwise. If is empty, set head to the new node, increment the size, and return this function right away. So if it's not empty, it's not going to go into the if statement. And so if the priority queue was not empty, the following statements will be executed according to the condition. So since this is a priority queue, we're going to compare their priority as we have talked before. Starting from 1 through 10, it's going from higher to lower priority. So this is how we will write it. So if the priority of the original head is less than, that means it has a higher number. So if the priority of the head is greater than the one that's passed in, priority, we're going to set this as our new head. So new node's next pointer will be head, and head would be our new node. We increment the size. Else, if it's not having a higher priority, that means the number is higher. Here's what we're gonna do. We're gonna loop through these elements and find the right spot for it. So create a temp pointer, EQ node cur, set it equal to our head, while cur's next pointer is not null pointer, and our new node is not having a higher priority of the one we're about to compare, then we're going to execute the loop. So here's how we write it. Next priority. Here's what we're gonna do. Cur, set cur equal to cur next, just to find the right spot. And once we exit the loop, that means we've gotten the right spot. So now new node next will be cur next, because cur is the one before the right spot. So cur next will be new node, and we increment the size. Right here is our enqueue function, and now we have our last function to implement. Void eq dpq, no parameter. If it's empty, there's nothing to be removed. So if it's empty, we're just gonna return. Else, the following statements will be executed. So create a temporary pointer, call it pq node, type enter temp node, set it equal to head, and head would be head to next. Then we set temp node equal to no pointer size decrement. Okay, this is all for the priority queue. We have one more thing to do. We're going to extract all these commands and store them into a priority queue according to the priority being given at the end of each line, and execute all these commands according to their priority after we've successfully stored them into the priority queue. So let's get started with that. We're going to include all the files we have created. Start from here. Include pq.h file. Include pq note.h file. Include q.h. Include one more thing. Q no. Include q no.h file. We're going to include the string library string using namespace std. Okay. Now let's make a function to store our command. To extract and store commit. Make it a void type. It doesn't have to return anything. Call it store commit. So it'll take in two parameters. One is the input file, which it'll read the commands from, and the other one will be a priority queue. We're going to store these commands to that priority queue. If string, no, call it input, and a pq. We're gonna pass in by reference as well because we're trying to modify it. Notice that most of these commands are made up of three parts, as we've discussed before: a actual command name, a message in between brackets, and a priority queue within the parentheses. So The only different command would be the print function. It only has a name of the command and a priority. So we're going to consider these two different cases when we code. As we can see, the print function doesn't have bracket. That's how we can differentiate these two. So as we can see that the name of the command would be 2 characters before the bracket, well, technically 1. So it'll start from the index 0 to this index. And we're going to use the find function from the string library to locate the indices of these two brackets and extract the message in between them. We do the same for the parentheses as well. Except for the print function. The print function doesn't have a bracket that stores a message, only has a priority. So we're going to do something different about that. So let's get started to implement what we've talked about. Get a string cur to store each line we read. We need the start index starting. We need a integer to store the starting index of bracket. So k star. Let's set it equal to 0. We need a bracket end. Set it to 0 as well. We need parenthesis start pr start equal to 0 and a pr end 0 as well. We need 3 variables to pass into the priority queue. One is the name of the command, a message in between, let's call it to change. To change, and an integer to store the priority. Let's start reading our file. While getLine can get line from the input and store it into current line, we're going to do this. If such and else for the print function. So if our find function can find the bracket, either left or right bracket, then we're going to store these commands as the first format into the priority queue. If current line find, let's do a left bracket not equal to -1, because whenever the find function returns a -1, it means that this character was not found in the function. So this is what it does. We're going to find bracket start find. If it finds it successfully, it's going to return the index of this character. So find left bracket, that's the starting index. Bracket and will be find the ending index. Parenthesis start find. Oh, I misspelled it. Oops. RT. Okay, and PR and find and in parenthesis. Now we've got all these indices from the brackets and parentheses. Let's actually extract the message, and now we've got all the indices that we need. Let's start extracting them. So command would be cur.substring. Just in case if you don't know what a substring does, what you can do is you pass in 2 parameters. One will be the starting index, and the other one will be the length of the string you want to extract from the original string. So what are we gonna do is we start from 0 because the command start from the first index, and the length would be, let's say we want 1, 2, 3, 4, 5, 6. We're at 6 now, and the index of bracket would be 0, 1, 2, 3, 4, 5, 6, 7. So in order to use the index of the bracket, we're going to do 7 minus 1, which gives us 6, and it's exactly the length of the command name. So bracket and minus so bracket star minus 1. This will give us the length of the command. And now now we're at the message. We named it to change. Let's do the same thing for it. String. Passing the starting index plus 1 minus bracket star. So there are a little bit of calculation here, but it's very easy to get through it. We'll do the same for the priority number. Since we had our priority queues enqueue function using 3 parameters, 2 strings, and an integer, the message we extract, the priority number we extract from the string would be a string. So in order to use it as an integer, we're going to use this little helper function, which convert the integer to string efficiently. It's just this little function s to I, meaning string to integer. So we pass in the same thing. We are using the substring function again. Passing the starting point plus 1, ending minus 1 minus the starting point. Now we've gotten these messages to be stored into the priority queue. We can actually call the function now. We go back to our main function. Let's create a priority queue. Priority queue. Name it my priority queue. So we store our commands to the priority queue. pq.in pq. We pass in command to change and the priority. Else if, because we have our print commands having different parameters, so here's what we're trying to do. We're going to see if we can find print in our cur. So use the find function, fcur find print does not equal to -1. That means it's found. We're gonna do set our command to print, print. We're going to find the starting and ending index for the parentheses because it doesn't have any bracket to start the message. So pr star will be the index of left parenthesis, and pr and will be cur.find right parenthesis. Then extract our priority. Use s2I function again. Do some calculation here from the starting point. Substring. Starting index plus 1. Ending index minus 1 and minus the starting point. This will give us length of the integer. Since we don't have any message for the to change, we're gonna set it equal to empty. To change will be set to empty. Okay, let's call our enqueue function and store the command into the priority queue. Enqueue and pqueue actually. Pqueue pass in command, pass in to change, pass in priority. Okay, now we've got our storing commands function done. Let's now implement the executing process. Since we're going to encounter decode command, we'll need a queue function to store the messages that we can operate on. So let's first store our command, calling the function store command, pass in our input file and our priority queue. We create our queue, my queue, let's call it. This function extracts and stores command into priority queue. This command will store, this queue stores messages to be operated on. Yeah, I could have made some functions to execute each of these commands, but I just made a big if-else statement to identify which command we're encountering. So I'm gonna stick with that. And let's try to implement it. Let's make a function, call it execute command. It's going to need 3 parameters actually. One is the priority queue that we're gonna read our commands from. A queue, which we're going to store the message to. In a output file, we're just gonna directly output whatever we have inside the function. So it'll make our main function a lot cleaner in this way. So let's do this. We have priority queue. We have a regular queue, my queue, and the output string. Pass by reference as well, output. So we'll be keep reading commands from the priority queue, and that's why we have our loop condition as while the priority queue is not empty, we're gonna keep reading it. While it's not empty, my pq dot is empty is false, is empty. We're gonna do such and such. Okay. Let's first do the decode command. Once we encounter decode command, we store the message we found right away into the queue. So if my priority queue, we're gonna call our peak function. We're going to call our peak function because our peak function will return a pointer pointing to the head of our priority queue, and we can use that pointer to access the command we have. So if the command is decode, D-E-C-O-D-E. If it's decode, we're gonna do, if it's decode, we're going to store the message into the regular queue. So my queue.enqueue, passing a message, we need my priority queue function pointing to its message parameter. My pq.peak function, we need a message parameter. And right after we encounter this command, we're going to dequeue. We're going to remove this command from the top of the priority queue, so then we can move on to the next one. My pq.dequeue, dpq actually. That's the first command. Else if we encounter replace. Here's what we're going to do. Else if we encounter the replace command, replace, here's what we're going to do. It says that it contains two characters separated by a comma. This is the original string, and after we execute this command, we are going to replace the first character with the second one. So it becomes S. So all the S appears in this message will be replaced with E. Because we had our peak function returning empty queue if the queue is empty, so we can check that as our condition. Let's create a string, call it raw code that we got from there. Set it equal to my queue.peak because my queue.peak returns a string. If it's equal to empty queue, empty queue. If it's empty queue, we're just gonna see out that command not executed, empty queue. That's what we're going to say if it's empty. Else, we're going to change all the occurrence of the first letter. So let's first extract the two characters in the message command that we got from the priority queue. Let's do two. One is original, one is new character. We're gonna change it to. So the original would be the first character we found in our message. That is original equal to my pq dot peak. We're gonna access the message at 0 because that's the index it's gonna have. And the new character, new char, will be since we have the comma in between the two characters, the index of this would be 2 because 0, 1, 2. We have successfully extracted two characters we're replacing. Now let's apply a for loop. Every time we see the OG character, we're going to change it to the new char. So, and start from 0. So, raw code.length. This will give us the length of the function, like how many characters are in there. So, I++ if raw code at index I is equal to OG, we are going to change it to the new char. Here is our for loop. And since it says that this will replace all the characters with an S to an E in the top string of the message queue, and then move that message to the end of the message queue. So that means this message will now get sent to the end of the queue. So we first pop this message.dequeue and then add it to the queue again. That way it goes to the end because queue is first in, first out. You have to get on a line which is from the end. So my queue.enqueue is going to have the parameter of the new raw code because we modified it. And after After these are executed, we can now remove the command from our priority queue. So my priority queue.dequeue is going to remove the first thing there. Now let's move on to next is our add function. It says that this will add an A after every in the top string of the message queue and then move the message to the end of the message queue. So whenever we see an in, we're going to add a 8 to the end of it. Whenever we see an in, we're going to add a at the. Whenever we see an in, we're going to add a after it. So how can we do this? What we can do is we create a new string and we're adding elements to the string. So whenever we see an in, we're going to add in first into it, and then right after that we add an a, which is the second character, to the new string as well. That'll be easier comparing to if you want to do it in the original string, because then you'll have to move all the characters after n by one, then insert that second character right after n, and then do the same thing for every other n you encounter. So I'm just gonna do it this way. Again, we check if the raw code is empty queue, then we don't have to execute anything. We're just going to copy and paste this down. Okay, else, this is what we're gonna do. Two characters as well. This will store our first character, and we're going to extract this by doing the same thing. To chain message at index 0. It's the first character we're going to see. And the second, new character, new char. Do the same for it. My priority queue.e msg at index 2. Same as before. We need a new string to store our final string. Let's just call it final string, and let's set it to empty at first. Initialize it to this. So now, whenever we see n, we're going to add it to the final string and append one more character to it. Would be less than the length of the raw code. Dot length increment I. Two conditions to check. If the ith index in raw code isn't the first character we wanted to see, we're just gonna add it to the new string and do nothing after that. So if raw code's ith index is not equal to this first character, which is 2, yeah, I know the name's a little bit weird, but it's fine. That's the job. Final string will have it appended at this code at final string. We're going to append it to the final string plus equal to raw code ith character. Else if raw code ith index is equal to 2, we're going to append it first and then add one more thing. final string add equal to the new char appended to it. Okay. So after this is executed, we're going to move the first string on top of the regular queue to the end. And this is what we do. This will complete our third little function, I guess. And now let's move on to the next one. We have remove. Check the condition. If the command is named remove, if the command is remove, also we check this, do the same thing, and else we're gonna do what it tells us to do. Let's see. Original string, and it's gonna remove this character right here. This will remove every V in the top string of the message and then move the message to the end of the message queue. So extract our character, call it remove, and my priority queue dot peak message at index 0 because it only have one. We get a final. We're going to store it in the new string as well. This will make things easier. String final string. Initialize it with empty line, and we get a loop to check whenever we encounter this, we don't add it to the string, else we're gonna add it to it. And I equals to 0, I less than size of raw code, the length, and increment I. If raw code at ith position is not removed, we add it. Final string add raw code index I. Else we just move on. We don't do anything. We just leave it out. And now we move. And now we move the message on top to the end. Might copy and paste it. Oops, this is another one. Okay. We got swap. Else if my priority queue dot peak command is swap swap. Check the same condition if it's empty. Else do it accordingly. Oops, I don't need this. So whenever we see N, we change it to A. Whenever we see A, we change it to N, and then move that message to the end of the queue again. So extract the characters. The 4 would be the first one. My priority queue dot peak going to message 0 and copy paste this. Call it after. This will be 2. Entering our loop, do the same thing. if we see ith index of raw code equal to before, we change it to the one after. Raw code at I equal to after, else if raw code at I equals to after, raw code at I is equal to before now. Move it to the end. Okay. We have one last function to go and then we're done. Like finally, else if we found print function my priority queue dot peak function command equals to print. Oops, where's this from? If it's print function, let's see what it wants us to do. This will print the value of the top string and take it out of the message queue. Alright, so again, check if it's empty. If it's empty, we're see out in the statement, else we're gonna output it to the file. Output, we're going to just output the first string on top of it, raw code. And then output, where's my put go? And we remove this message from the top. So my queue.dq. Alright, this is our last print function. So we're looping through the priority queue until it's empty. Every time we finish a command, we're going to remove this command from the priority queue. So dq for priority queue, dpq. This will complete our executing command function, and let's call it and see if it does the job. Execute command, right? We're passing in our priority queue, my pq, my queue, and the output file. Hey guys, this is me a little bit after I finished the video recording. I found a inconsistency here. So I called mypq.dpq function here, but then I decided to put this statement at the end of this big while loop. It does the same work, but I forgot to record it into the video, so I just wanted to clarify on that. There are some typos and spelling errors I had in this code. It was a little bit distracting coding while talking, so hope you guys can forgive me on that, but the logic still applies. So I'm gonna show you guys how I run the test cases for homework 4 and repel. I've uploaded the answers input and the test script onto repel, so we can simply execute this little command and then it'll test it for us. sh test4.sh, that's the name of the script. So it's gonna tell us if we pass the test cases or not. Okay, yeah, see, that's the job. There are a lot of optimizations we can make in my code. We could have applied template, which makes it a lot more flexible, reusable. We could have applied some kind of inheritance between the priority queue and the queue class. So we didn't have to write so many codes. And for these as well, we didn't have to create two variables inside each function. We could have made two general ones right after the function starts, but I chose to make it this way so we can reinforce the logic again and again, I guess. So this is pretty much my implementation for homework 4. I hope you guys found this video somehow helpful, and if you guys found any errors, please feel free to reach out to me or leave a comment down below. Or if you have any questions or problems you would like to discuss with me, please do that as well. I'll be very happy to discuss it. And thank you guys for sticking with me. I'll see you later.